So this is an alkyl halide. So for example, again, there are four steps. The first one is talking about the parent. The second one is talking about um, the numbering of the parent. The third one is about the naming of the substituent, in which here we're talking about the alkyl and the halide, okay? Because this is an alkyl halide. And then the last one is making a whole name. So for example, we have here 1, 2, 3, 4, 5, 6, 7. The carbon which is longest is has 7. So that is step 1. Step 2, uh, you can either number here 1 or in this part 1. So we number here 1. Why? Because the first branch, the substituent, starts at a lower value here. While if we put number 1 here, we would have 1, 2, 3, number 3 as our first branch. So basically, we will number here 1. Okay, that is the second step. The third step is what are those substituents? So this one is a methyl, this one is a methyl, this one is a bromo. Okay. So after that, step 3, you go to step 4. So for step 4, of course, bromine will be lower in letter, alphabetically arranged. So you have number 5, you have a bromo, and you have number 2 and number 4, which is methyl. So we put the di. So that is 2,4 dimethyl, and then putting the 7, which are single bonds. So that would be a 5 bromo 2,4 dimethyl heptane. So how about this one? So here, number 2 would be again from here would be number 1 because the branch would occur at number 2, which is a lower number. Unlike here, it would be a number 3. So 2 bromo 4,5 dimethyl heptane for 7. So 4,5. So you have still methyl for the part 3. How about this one? You have, of course, you will be numbering on 1 for carbon because we're numbering the 1, not the bromo for 1. So since the first bromo appears here, so that would be number 1, 2, 3, 4, 5. So that would be pent. If those are single bonds, you can see the hydrogens. Those are single bonds. So you can analyze. You should know how to analyze now if it contains a double bond or a triple bond because you can count the valence. Okay, you can count the valence. So whether it be notated as this, which is what we call this a condensed structure, you should still know how to identify double bonds and triple bonds. So for in this case, as you can see, you only have single bonds because of the hydrogen placement. So you have one bromo, and then number 3 would be chloro, and number 4 would be methyl. So by naming convention, we would start with bromo, and then proceed with chloro, and then for methyl. So its name would be 1 bromo dash 3 chloro, and then you would have the 4 methyl pentane. Okay? So more example, how about this guy over here? So you'd start with from the right. Why? Because you will have both number 2 as the carbon with substituent. If both has the same number, we would resort now um to alphabetical order. So bromo would come first with methyl. So number 1 would be this carbon since the alphabetical order would be bromo before methyl. So the numbering would be 2 bromo and then 5 methyl, and then there would be 6, so that would be a hexane. So parang mani, masayon. Okay? And then next is organic halide. So organic halide. So for this one, this is only methane with an iodine, so we call it iodomethane. So since there would be only one carbon. How about this? So this is chloropropane, or we can also call it isopropyl chloride. So now this is not a UPAC. So but again, the book itself is introducing you to other systematic names. Again, IUPAC is a systematic name, but were also some nations already established a systematic somewhat naming for your substances. So it's still valid. Why? Because some compounds are only made from certain countries. So therefore, we will somehow adapt not the IUPAC name because as they transport or export it to other countries, the name of those substances would still bear those names that they have developed even if it is not IUPAC. So still it would be valid. 2 chloropropane. Why? Because number two, you have a chloro, or we know that from three carbons and then one available for bonding is on the second part. We call it isopropyl. Okay, so that's why isopropyl chloride is also valid. How about this one? This is an arene with a halogen. So again, that would be an alkyl halide. So anyway, we don't have alkyl here. We all only have bromo, and this is hex. So cyclohexanol, cyclohexane. So we have bromo cyclohexane. Okay. How about here? More example. Um. Anyway, so for arene group, actually, there are compounds that again not IUPAC but they're common names. So we have to be familiarized with them. For example, we have of course benzene. We have toluene, the benzene with a methyl group. So we can actually call it also a methyl benzene, but it is more known as a toluene. So we have to know that since it's usual, common organic compound. And then another one is a xylene. A xylene, xylene is a bromine. I mean, a bromine, a benzene with a metal group. Okay, and that metal group is usually in the ortho. But anyway, xylene is also common, so we have to be familiarized with them. With them, Indin is not so common, but anyway, we have. You can still use this. Some of these basic compounds for arene. You can use this during quizzes and exam. Of course, I would allow that because I don't really want you to memorize. This one is also common, naphthalene, a double-sided benzene. So we call it naphthalene. So some ayupak naming would be, of course, or maybe a not really an ayupak, but a um, naming convention, which is also logical, would be uh, phrasing it as naphthalene, not really as a dibenzene. No. So this one is a biphenyl. So again, this is a double ring, but with a what do you call this? The carbon here is not a double sided, meaning it has a separate six carbon. So we call it biphenyl. Why? Because uh, that's what its name is, phenyl, biphenyl. Okay, this is also common, biphenyl. It's an organic substance, and this one is anthracene. Not so common, but it may be. So just go back to this basic structures of arene to refer them. This one also, another one, a triple benzene ring, phenanthrene. So there are two, anthracene and phenanthrene. So usually this occurs in medicines. Anyway, medicinal chemistry is or clinical chemistry is also related to organic chemistry and even to your course. As a marine biologist or a bee fisherist, organic compounds um, which are found in the aquatic sources, especially for medicine purposes or for exploitation of medicine, like toxins. Some it could contain these organic substances, anthracene and phenanthrene. So just go back here if ever. I also go back to these tables if ever. So these are the common aromatic compounds. Again, toluene, phenol. You have the alcohol already, OH. Okay, so that is a phenol. And then you have an aniline, a benzene with a amine. So we call it aniline. NH2 is for amine, a functional group. And then this one is an OCH3, acetophenone. I think this is a ketone. So the ketone group, as you go back to the functional group, that would be the CO, and then you have the COC, and then you would have the R, which is a benzene ring. So this one is an acetophenone. Just go back to this table again. You can still use this table. Common names of some aromatic compounds. If ever there is a quiz or a one, you can use this table as long as not the examples that I will be giving. Okay, this one is a benzaldehyde. Again, that is an aldehyde. May I pause?